bisection method. So this is actually very simple. Unlike Newton-Raphson's, you don't have to differentiate here. So let's walk through. We are given this f of x. This equation has our f of x, and we are not being told what our intervals are. So first of all, I advise you that you need to put this into your calculator, right? Then you need to start inputting numbers. Start with 1, start with 2, 3. Yeah, usually 1 to 3 most of the time, or decimal point. So your goal now is to find a number that when you input, it first of all gives you a negative. So let's assume, okay, we don't need to assume, it's actually solved here. So right here, they input 2 and they input 3. So when they input 2, it gave them a negative answer. When they input 3, it gave them a positive answer. So the reason why we want positive and negative, because when you look at number line, we have negative on the left, positive on the right, and our goal is to get to the center, centralized, in which 0 is like the center of balance and whatnot. So that is why we want a negative and a positive, not positive and positive. If you get positive and positive, the center is not equating to 0. You feel me? So you need your center to be equating to 0. That's why it has to be negative and positive, right? So this method is actually fun when you find the first two number that gives you a negative and positive. For example, here 2 and 3 gave them negative positive, so they had to look for the center of 2 and 3. That was 2 plus 3 divided by 2, taking the average number, so it fell on 2.5. Actually, your calculator can actually give you the number that gives you the number that you input that gives you 0. But let's just solve like these guys. You always have to divide by 2. So you input the 2 into your x into the equation. That's your answer here, 2.5. So now as you can see, it is giving us minus 3375. Cool. That's a negative answer. So we go ahead and say, okay, our root is in between x1 and our 3. Now, the reason why it's in between x1 and 3 is because if we input, let me input that into calculator. I'm going to pause now and input my 2 into calculator and say the answer. Okay, I'm back. So if you input 2 into this equation, right, it's going to give you minus 9, right? And now that we just use 2.5, it gave us minus 3. So the reason why we are saying our root lies in between minus x1 and 3 is because minus 3 has brought us closer to our 0, unlike minus 9. If we had gotten minus 12, we'll say, okay, no, it still lies in between 2 and 3. But no, because minus 2.5, or sorry, 2.5 had brought us closer on the negative axis. It has brought us closer to 0. That's minus 3. So let's assume we are, how do I draw a line right now? How do I draw a line? Draw. So if I do this, right, and this is center, so this was where we were before, minus 9, and now we just came here for minus 3. You get, but our goal is to get here. So yeah, I'm going to erase that now. So that's why we are saying our root lies in between the answer that 2.5 has given us and 3, right? So return that. I need my cursor. Okay, so that's why here you can see that we say the statement is the root lies between x1 and 3. So we are going to go again, second approximation. We do 2.5 plus 3 divided by 2, we get 2.75. When we input 2.75 into our equation above here, we got 07963. So now this 07963, I'm sure it brought us closer also, because that was why we kicked out 3. Initially we said x1 and 3, but because this guy brought us closer, let me input 3 into my calculator and let's see the figure. So 3 and 3, yeah, 6. So imagine when it was 3 gave us the positive 6, but now that we input 2.75, it gave us 0.79. So these two are actually closer. That's why we're going to say it lies in between these two guys. Like, we're 100% sure our answer lies in between minus 3.3 down to positive 7.7. So we are going ahead again, dividing by 2.75 plus 2.5 divided by 2, so we got 2.65. So we did the same thing, input 2.65 into our equation, and we got minus 1.4. So this now has already kicked out our x1.